Okay, we're going to talk about the derivative of an exponential and the slope of its tangent. So in the last two, we talked about how to derive a function, especially an exponential, when we have e to the power of x. Okay. Now, to determine the equation of a line tangent to this, what we're going to need to do is we're going to need to derive this function and then plug in our value at this specific point to find the slope of a line at this point. So we're going to derive our function here. We'll put it in terms of f at x again. So f at x is equal to e to the power of x over x squared. There's two ways we can go through this. We can use a product rule or we can use a quotient rule. As a product rule, we could turn this into x to the power of -2, thank you, times e to the power of x. And as a quotient rule, we leave it as is and go through. So you know what I'll do? I'll try to do it on both sides, and assuming we don't make an error, we should end up with the same derivative. Okay? So as a product rule, f prime x, we derive the first term. The first term becomes negative x to the power of -3 times e at x plus x to the power of -2, and the derivative of e at x is e at x. On the other side, we'll start up here because this one will take a little longer. X prime x, f prime x. We find the derivative of our first term, and derivative of e at x is e at x multiplied by x squared. Subtract our original, which is still e at x, times the derivative of x squared. And the derivative of x squared is 2x, all over x squared squared. We'll see if we can simplify this a little. We can factor out e at x in the top one. So we get e at x, and we have x squared minus 2x. And this becomes technically x to the power of 4. Okay. And our other example here, we'll jump back to the left. Let's see what we can do here. On top we'll have e at x times -2 plus, yeah, I think we should factor it 4 to be all honest. Let's factor out our e at x in both of the terms and then move everything to the top and bottom of our fraction. So if we factor out our e at x, it's a great idea. We'll have -2x to the power of -3 plus x to the power of -2 in this case. Okay, from here, our values, these would become the bottom. Both of them would go onto the bottom. And we'd be left with e to the power of x multiplied by -2 over x cubed plus 1 over x squared. Okay? Both looking pretty different. We can get similar bases by multiplying our values. Sorry, say it again. So I'm trying to draw a similarity, and I've noticed that on our right, the bottom of our function is x to the power of 4. So I'm going to make both of these denominators x to the power of 4 by multiplying this fraction by x on both the bottom and top, and multiplying this fraction by x squared on both the bottom and the top. That will give us common denominators, therefore we'll be able to add. We still have e to the power of x outside. This will become -2x over x to the power of 4 plus x squared over x to the power of 4. We can combine what we have here with e to the x. We'll have -2x plus x squared all over x to the power of 4, which is identical to what we had just above here. So really, depending on what method you like, can we do anything else from that? We could probably factor out an x in each. Yes, we can. We can simplify on this end here by factoring out an x at each point. Okay? So if we were to simplify this, factoring out an x in each point, we'd be left at e to the x. Here we'd have -2 plus x over x cubed. Okay? And then it may be beneficial, it may not, to distribute our e back into our values on top. But this is a good form, and we could do the exact same thing we had done up here. But what's more important is the idea that, remember, we're trying to find the slope of a tangent at this point. So we're looking at the point of when x was equal to, I believe it was 2. I'm just going to double check. Yep. when x was equal to 2. So we're going to use this form because it looks like it's the most simplified form we have. Okay. So in this case, we're going to end up with e at x multiplied by negative 2 plus 2 over 2 cubed. What will end up happening here is we'll have e to the power of x. Negative 2 plus 2 is 0 over 8, which means it gives us 0, which means e, oh, and sorry, I should have replaced the x with the value of 2 also. But no matter what this value is here, when we multiply it by 0, we'll be essentially eaten up by 0. So this is a horizontal line. So the slope of this line would be y is equal to 0. Okay? So we have a line that is horizontal on our graph. And I'm sure if we plugged it into a graph, maybe we should try that. Do I have any graphs floating around? I think I do. Quickly bring up a graph here. We're going to plug that value in to see if we can't find out exactly where that was. Okay? Our original equation, okay, I'm just going to scroll back so we can find it, was e at x over x squared. So let's plug that in and see what that gives us. I think we can do that. X are 2. Is this our function? No, I don't think this gave us... I don't know if that's giving me the correct e for our value. Let's go 2.718, was it? Is roughly the value. Oh, sorry, it's not to the power of 2, it's to the power of x. That was my error. There we go. And here we go. At our point of 2, it looks like we have a horizontal line here. Okay, that's where our critical value is. It's turning around. So we found the correct slope when we went through this. Again, you could have gone through using chain rule or product rule. The idea is plugging in the x value at the end to find the slope of the tangent at that point.